Hello, class. Today I want to talk to you about my Data Science Practicum 1 project. What this is a 2052A rules web scraping project, and I will kind of go into some detail along the way. So what is the 2052A rules? These are a set of rules that were designed by the Federal Reserve Bank following the Great Financial Crisis of 2007 and 2008. As many of us remember the collapse of Lehman Brothers and banks that were too big to fail, these set of rules apply the Basel III liquidity coverage ratio as a requirement for large U.S. banking institutions, kind of reducing the potential for too big to fail or failures of the banking industry that could cause systematic collapse of the economy. So why were they developed? They are a prescribed set of guidelines that every bank is required to adhere to. And it basically tells the Federal Reserve and the public, because we do have to disclose this on a quarterly basis, how well are we handling our liquidity, ensuring that we've got a buffer over a 30-day stress period. So my banking institution is required to submit this on a daily basis in currency, and by providing this information to the Federal Reserve, they can kind of get the pulse on any liquidity stresses that could be potentially occurring. For an example, we just experienced a liquidity crunch during the beginning of the pandemic. So by looking at this information on a daily basis, they can get a understanding of how the large banking institutions are handling and any sort of potential actions they might need to take in order to preserve our financial system. And so the Federal Reserve is a banking institution. Banks are really old and kind of behind in the ways of technology. So when the Federal Reserve provides rules and updates to the rules, they're just dropped on a PDF on the Federal Reserve's website. This goes along with a lot of other regulatory documents. They just get dropped, and analysts internally are required to read through the tables and see if there are any material changes. And as you can imagine, reading through hundreds of pages of legalese documents and a bunch of tables, this leaves a lot of room for error. I mean, it's boring, and and you can easily overlook something which could cause an MRA, which is a matter requiring attention by the Fed, or findings by auditors, all of which can be really costly to a banking institution. And currently, with COVID and zero interest rates, banks are kind of stressed on being able to turn profits. So we have to keep our expenses low. Going back to why this is a problem, because we don't want fines. So the purpose of this project is to go directly to the Federal Reserve's website and pull all the 2052A rules down. So this will just prevent us from missing any material changes. We can pull down the data regularly and drop them into a data frame and look to see if there are changes and update that data within our liquidity engine that we use on a daily basis to publish LCR and to file 2052A to the Fed. So how are the rules scraped? I used 4 libraries from Python, Tabula, to pull down the data from the tables, Pandas and NumPy and regex to go ahead and transform the data. As you can see below, this is what one of the tables looks like. So this is the data that I was scraping directly from their PDF that they have up on their website. So again, using Tabula 2.20, I went ahead and scraped all the data off of the 2052A rules that are current from the website. Each rule was transformed and concatenated into a table, and the end result is a data frame containing all the rules versus us having to look at a PDF. And so again, this is kind of my process. I went ahead and called the libraries that I needed. And then I pointed directly to the FRB's website, which was my file. And then using Tabula, I went ahead and pulled down all the tables from the document. So we can see that I wanted to grab all the tables. I'm saying that there are multiple pages, and encoding's UTF-8. In this scenario, selecting string equals true and lattice equals true was able, were the two requirements for me to get these tables to pull down appropriately. So if you're ever using this program in the future, the website for Tabula has a help FAQ that's useful in terms of troubleshooting. So this is what worked for me. And then by some investigation of the data, I determined that the first 14 tables were not required at this time. I was only concerned with getting the 2052A rules. So I created a data frame, 2052A, that captures tables 15 through 228. And then, I was able to get a look at the view of the data as it came out of the PDF, which you can see in the hexagon at the lower right-hand side. So obviously requiring a lot of data transformation to get this into a format that I could drop into a table. So there are three main transformations that took place. I'm going to outline the first transformation here. So I will go ahead and identify a table, go ahead and select the first and third columns, reset my index, drop the name of the LCR rule down into a row so that I wouldn't lose it. And then I gave dummy column names to the data frame so that I could continue my transformation. So this is kind of the first step. And then the next step was what got us into a format where I could concatenate all the rules into a tabular format. So again, creating a test rule so that I could kind of babysit it. A good deal of these tables were not created equal. A lot of them kind of had some strange issues, like not liking column names as the way that I had initially designed it. So this process, while a little clunky, allowed me to just kind of get eyes on the data. And so, I kind of ran through, I reset my index, I transformed it to a long format. I moved the LCR rule name down to the first row, which was able to, get it into one row containing all needed information. I just, dropped duplicate column names, got my headers all in line, showing the LCR rule, because otherwise that would have just shown up as the rule itself, so 61. So it needed a generic title. Obviously all this moving around, the indexes got a little out of whack, so I set my index from 1 to 0, dropped any NaN columns, and then, I would get a view. That test rule is just to get a look at it, and then it would convert to the name of the rule. And then this would allow me to get a view for completeness, just calling OF65 for an example. So I kind of worked through this process at a very high level for all 212 tables. And then I went through and concatenated all the tables. I initially started by creating an HQLA outflow and inflow table. And this is just an example of how one of the rules was concatenated into my outflow table. And then I went ahead and just viewed them for completeness. So dropping them in Excel and just getting eyes on it in a different format, because Jupyter notebooks tend to not allow you to look at the whole table. So this kind of was giving me an option to look at it in its entirety. I went through and created the whole table, so concatenating inflows, outflows, and HQLA. The next step was a little bit of housekeeping. So I went ahead and I pulled the table names into their own columns. This is only because that's the way that we utilize the information from my organization. We do separate out the table name and then look at the PID or the product ID separately. So this just used a regular expression to go ahead and grab the table name from the PID, which would have had all of the numbers associated with it incorporated. So then, and then I wanted to clean up the PIDs. So just getting the numbers separated by comma. And I had to clear up some white space, get rid of like extra commas, and then it was pretty much good to go. So these were the two last steps that I wanted to do on the tables before I would call myself complete and have this data useful to be used at work. So now that this project is complete, it does add a lot of value to my baking organization, as it provides a framework to safeguard us against overlooking any material changes, and it just reduces the potential for us to have findings or MRAs, which is definitely a value that the organization could use. So our end result is a complete list of the 2052A rules. They're current from the Federal Reserve's website in a tabular format that can be utilized to map all of our LCR and our balance sheet, preventing issues of oversight. I definitely recognize that there is a lot of room for improvement on this project. I think that now that I know it works, and you know, I'm going to go ahead and bring this forth at work. And as I continue to pull down the data and do regular checks, I'll probably be making some improvements to the code. But, you know, given that it's a global pandemic and I've got kids e-learning and I'm taking a bunch of classes for grad school, I'm actually really satisfied with the end result. And I think my employer is definitely going to be happy as well. So this is my project. If you want a little more detail or to look at the code, just go ahead and visit my GitHub page, which is noted here at the bottom of the slide. Thank you for taking time to check out my project, and it was definitely a good learning process.